Hello, we are Connor Felt, David Hicks, Callie Stewart, and Xavier Wilds. We are from the Iowa State University Department of Industrial and Manufacturing Systems Engineering, and we are taking IE 441, or Senior Design, in the fall semester of 2017. Our project was at Danfoss Power Solutions in Ames, Iowa, and we were tasked with designing plans for a new assembly line for existing products Danfoss has. I want to provide a little bit of background on our project. Danfoss is currently running many assembly lines, and we are focusing on one of those assembly lines that produces many different pumps and motors with thousands of variations. Danfoss is splitting this line into two lines, one of which will take 80% of the current line's volume and is being designed by Danfoss engineers. Our group is tasked with designing the assembly line that will assume the remaining 20% of the line, as that is where a majority of the variation takes place. The goals of the project were to reduce operators on the line from 4 to 3, eliminate safety concerns on the existing line highlighted by Mary Greeley Medical Center, mitigate two quality concerns Danfoss had, and reduce the potential for improper orientation of the trunnion and lifting bracket. When we analyzed the current state of this line, we found out that the line is 960 inches long, there are 10 stations, and at the end of the line all of the pumps go to a test stand. The line is designed to have 8 operators floating between those 10 stations and the test stand. There are also areas of concern in terms of safety and quality on the current line. Our team watched over 28 hours of video in order to do a thorough line balancing. We also used information we obtained, combined with information given to us by Danfoss, to analyze the quality and safety concerns in order to address them in the future state design. We gave Danfoss a few ideas for line designs, and the one they selected for implementation was a new, 2-station line that is only 330 inches long. This alternative will include a kitting station to hold inventory for the line and will still have a test stand at the end of the line. The line will have updated equipment and will be able to eliminate at least one operator and address the quality and safety concerns highlighted. Shown here is an AutoCAD version of the kitting station. Since this line had such high variation, keeping the parts in inventory at the beginning of the line has many advantages to the operators on the line, the people stocking the line, and is a time and space saver. The operator at Station 1 will assemble all the parts in the kitting station using barcode scanners to pick the parts, ensuring a high level of accuracy. Then take all of the parts back to Station 1 and begin assembly. This station will be 5 shelving units tall and have an L-shaped design for the convenience of the operator picking the parts, the person stocking the parts, and to have more clearance in the aisle. Some of the quality concerns Danfoss had were that the trunnion and lifting brackets are sometimes assembled in the wrong orientation. In order to fix that potential error, Danfoss will install a vision system, shown on the left, in which a camera is used to analyze the pixels at a very detailed level in order to tell if the part was assembled correctly. Another quality issue Danfoss wanted our team to address was the wrong valve plate and SCR assemblies are sometimes used, because the variations of these parts look very similar to each other. To alleviate this risk, barcode scanners will be used for those parts. Each valve and SCR assembly has a barcode placed on it at the supplier level. Barcode readers will be installed on the line, and the operator will place the part in the barcode scanner, like the valve plate shown on the right. This will ensure the correct part is being used. The two safety issues we needed to address were that the housings are manually flipped and torques are done manually. Not only could these safety concerns strain the operator, but also pose quality concerns with inconsistencies. By implementing a pallet that allows the operator to rotate the housing with the help of the pallet, and using DC electric torque tools, we can help keep operators safe. Another aspect we wanted to consider when doing this project is that being a good steward of the environment is of utmost importance to Danfoss as a company. For this project, any old or outdated equipment that gets updated is donated by Danfoss to a local resource company and recycled accordingly. Additionally, energy consumption will be reduced by 10% due to new equipment. When they are rebuilding the new line, as much of the existing equipment as possible will be reused. Shown here are the financial implications of our decisions. As you can see, the total savings we are projecting for Danfoss due to reducing safety and quality concerns, reducing scrap, rework, and maintenance time, and eliminating one operator position is $219,000 annually. The total cost to Danfoss to implement this new line will include new equipment and installation and will come in at only $200,000. As a note, there is a plant transformation credit applied here because Danfoss is in the process of rearranging all of their assembly lines. So they had money allocated to this project to begin with, and the line would have had to be flipped regardless of any improvements being made. Because of all of those financial implications, Danfoss will see an IRR of 94% with this project and recoup their costs after just 1 year. The NPV of the project is $325,000. We would like to thank Danfoss and the team we worked with for allowing us this opportunity to develop our skills and grow as engineers. We would also like to thank the ISU IMSE department for the many wonderful experiences during our time here.